Okay, let's look at a test review. So first, if I have this graph, if I want to estimate the value of f prime at 50, that's just the slope of the tangent line at 50. So I draw a little mini tangent line, but I see that if I look at that tangent line, it's going to approximately look like this, right? And so if I had to approximate it, it looks like it's about 20, and it looks like this. So actually, let me be a little bit more careful. Let me let it get even bigger. So if I go all the way to this thing, it looks like it goes to there. It's like this thing goes to here. So if this is 30, it's 35. So it looks like it's the change in x is 60 minus 35. And it looks like the change in y would be from about here, which is 400. This is going to be 600. So that's about 700. About 700 minus 0. Or 700 over 5 gets it 40, 25. So that'd be 4 times 7 is 28, right? Is that right? No. 4 times 7, yeah, 28, right? It's gonna be 28. Just to make sure that my brain is working properly today. I hate you so hard. Why do you never have on number lock? Okay, 28, yep, brain's working. So that is approximately 28. Now it says, is the derivative at 10, which the derivative at 10 is going to be this, the slope of the tangent line. And then the derivative at 30 is here. It says which one is bigger. So it looks like this one is a little more negative. So I think this is a no. It looks like the derivative at 30 is actually bigger on the number line than the derivative at 10, because the derivative at 30 is more negative. Okay, so that means it's going to be like this. So that'd be a no. Then it says, which is bigger? Part C says the derivative at 60, which is about the slope of the tangent line, or, so this is slope of tangent at x equals 60, and this one over here represents the slope of the secant line from or on the interval from 40 to 80. That's what this represents. So if I look at the slope of the secant line from 40 to what's 50, 60, 70, 80 here, that's going to be the slope of the secant line. So which one is bigger? Yes, this slope is more positive than this slope. So yes, that's true. Since slope of the secant line at this is greater than the slope of the secant line on this. So since the slope of the tangent line at 60 is greater than slope of secant on from 40 to 80, then that's why f prime at 60 is greater than that quotient. All right. Then it says it wants us to find the derivative of this function. So I'm going to take a screenshot, and then I'm going to copy that thing. Copy. Okay. So let me do a new page right after. And so let's find the derivative of this using the limit definition. So the derivative of g. derivative of g is the limit as h goes to 0 of g of t plus h minus g of t over h. If you don't have that memorized, you should. We're going to put up a little scratch work right here, and it's going to be 1 minus 2. If I have to find what happens when you plug in t plus h, you're going to get this over 3 plus t plus h. So in other words, it's going to be 1 minus 2t minus 2h over 3 plus t plus h. So all of this is just equal to t plus h. So I'm going to paste it right here. Well, that is t plus h minus g of t, we said was 1 minus 2t over 3 plus t. So now that's a limit we have to evaluate. Well, the first thing I'm going to do is I'm going to pull out the 1 over h. I'm going to put out front. So you're going to have 1 minus 2t minus 2h over this guy up. 3 plus t plus h minus 1 minus 2t over 3 plus 2t. So I'm going to pull out this stuff divided by h in front. Instead of dividing by h, I'm going to multiply by 1 over h. Well, now I have two different fractions that I want to combine, so I have to multiply the first one by this well-chosen one, and the second one by this well-chosen one. Notice you have to do it on the top and the bottom, or it's not equal to 1. So when you do that, you're going to get the limit as h goes to 0 of this 1 over h times 1 minus 2t minus 2h, all that times 3 plus t, minus 1 minus 2t times 3 plus t plus h, all over our common denominator of this thing times this thing. Okay. So I'm going to take all this and what? No. That's fine. So if you allow me, I'm going to come right over here. And I'm going to have the limit as h goes to 0 of, let's get all our terms first. So 1 is going to now distribute. 1 is going to hit each of these, and it's going to give me a 3 plus t. And then I guess our 2t is going to distribute. And negative 2t, it's going to hit both of those. And it's going to give me negative 6t minus 4t squared. Minus 4t squared. And then negative 2h is going to hit both of these. And it's going to give me negative 6h minus 2ht. So I have a 3 times 2 terms. I should have 1, 2, 3, 4, 5, 6 when I'm finished. And that's what I should expect. Then over here, I'm going to be careful and I'm going to make sure that I'm subtracting all of this. So first, a 1 distributes and 1 hits each of these. So if 1 hits each of these, it's going to give me a, let me go ahead and erase this. Go ahead and move this over just a little bit. If you allow me to come up here. It's going to be subtracting everything in parentheses right here, which is going to be 3 plus t plus h. And then you multiply everything by negative 2t. So you're going to get negative 6t minus 2t squared. Over just a little bit, open that up just a little bit. Minus 2t squared, and then minus 2ht, minus 2ht, all over our common denominator of 3 plus t plus h, 3 plus t. And don't forget, all of this stuff is multiplied by 1 over h. So does stuff cancel out nicely? Well, I think we see that this 3 and this 3 cancel out. T and the t cancel out. 6t and the negative 16, negative 6t cancel out. Negative 2ht, negative 2ht cancel out. So what's left over is 1 over h times, guess I have negative 4t squared minus 6h, and then minus h plus 2t squared all over my common denominator of 3 plus t plus h, 3 plus t. Where you'll get into trouble is if you try and do too many steps at once. Let's not do that. So here, I guess I have negative 2t squared minus 7h all over. Oh, should that be a 2t squared h? Let me see if that's going to be t squared h. So 4t squared. Okay, so something is going wrong here. This. So in my terms, 1, 2, 3. 3 hit everybody and gave me this. T hit everybody. This should actually be a back here. On this term, this should have been a minus 2t squared. So if I hit that minus 2t squared, then that means that both of these would cancel out nicely. Okay, so now it's this, which is going to give me negative 7h over 3 plus t plus h and 3 plus t. What does that really mean? That means we have h over h times negative 7 over 3 plus t plus h times 3 plus t. So this is just equal to 1. As h goes to 0, this is going to go to 0. So you're going to end up getting negative 7 over 3 plus t 2 times, or in other words, squared. So that is your derivative. Okay, not easy, but super doable. So then if you want to double check yourself, know that you could go to something like a Wolfram Alpha, and you can type in the thing that you had. So I can just double check it by typing in the thing that I had, which was 1 minus 2t divided by 3 plus t, and you can say derivative. And then, yes, it should give us exactly what we think we're going to get. Accept and close. Why is it being so slow? Because the internet here is slow. Oh my goodness. Wow, that should not be that slow. Okay, moving on. I assume that's right. Wow, that is horrible. What if I just do, give me just 1 second, x. What if I make it x? Is that going to make it any better? Yeah, no, it shouldn't. That's ridiculous. Okay. So now what we're going to do is go back here, and it wants us to either take these limits or show that they do not exist. So I'm going to take this limit here. I'm going to take a screenshot, copy, so add a page after. Oh no, that's fine. Should paste, so it looks like this. Okay, so if I'm taking this limit as x goes to infinity, I see that you end up getting infinity over infinity, so that means we have to change the form. And so the way that you do that is by multiplying this by 1 over the highest power. So we get the limit x goes to infinity of root 2x plus 1 over x, all that divided by 3x minus 5 over x. Well, why is that great? Because, well, first off, on bottom you can write it as this minus this. And on top, as x goes to positive infinity, x can just be rewritten as the square root of x squared. So that means that on top, we're just going to rewrite that as the square root, a bigger square root. One big, well, no. That means this is just the square root of 2x squared plus 1 over the square root of x squared. But what does that tell us? I think that you'll see that we can write that as one big square root of 2x squared plus 1 all over x squared. On the bottom, we have 3x over x minus 5 over x. And if I can do it 2 steps in one, which I think is okay, it's really going to be that thing over x squared and that thing over x squared. So now when we simplify, I think we just get this plus 1 over x squared divided by 3 minus 5 over x. As you let x get really big, that goes to 0 and that goes to 0. So you just get the square root of 2 over 3. So that means that our original function, so the square root of 2x squared plus 1 over 3x minus 5 has a horizontal asymptote at y is equal to the square root of 2 over 3. Let me go back a couple. So now you have this one. Hit Control Copy. Take screenshot. No, not in Messages. No. I don't want to send that to somebody. Copy. Okay, this. Ooh. Go a new after blank. So I'm going to hit dirt, paste. So if I have to do this limit, I agree, right now it's over 1. If I let x go to infinity, you're going to have infinity minus infinity, which makes no sense. So you end up multiplying it by the conjugate. So I'm going to end up multiplying it by this thing plus an x and this thing plus an x. When I do, the top is going to give me the first one squared minus the second one squared all over this, right? But the square root of x, the square root of all that stuff squared just cancels stuff out. And so we're happy that these cancel out nicely. You're left with 1 over square root of x squared plus 1 plus x. I think it's pretty clear that as x gets really big, this whole thing is going to 0. Because now as x gets really big, the bottom is just going to grow without bound, and this whole thing is going to 0. Right? Okay. So the square root of x squared plus 1 minus x has a horizontal asymptote at y equals 0. All right, that one was relatively doable. Let's see. I'm gonna take a screenshot, copy, and then add, whatever, okay. Oh, why it does that. So here, again, it's this idea of 1 over the highest power. As x goes to infinity, that's why we use 1 over the highest power. So in this case, what it's going to give you, because right now, if you try and plug it in from the beginning, you're going to get infinity over infinity, which makes no sense. But if you do it this way, you're going to get 1 plus 1 over x squared. Is that right? Oh, 1 plus 1 over x. On the bottom, you're going to get 3 plus, okay, you're going to get 3 plus 1, oh, sorry, 3 over x squared plus minus, 1 over x. So now you let x get really big, the top is going to 1, but the bottom is going to 0. So this thing is actually going to blow up to positive infinity. So this limit does not exist because it is infinite. So you can either say it's infinite or does not exist, but you probably want to say it's infinite, so that's why it does not exist. So x squared plus x over 3 minus x has no horizontal asymptote. Has a slant asymptote, but we'll talk about that later. Okay, so then you go back to this, and we're talking about this one, and after this one, I'm probably gonna have to take a break and come back and talk to you soon. So copy. So now what do we have? 1, 2, 3, oh, here, this, and I'm gonna do blank, and I'm gonna hit paste. Okay, so for this limit, notice I could break it up into the limit as x goes to 0 of the sine of 3x over x times the sine of 5x over x. It's really close. I know the limit as theta goes to 0 of the sine of theta over theta is 1, right? So I wish this had a 3 on bottom, but the only way that that can happen is if I multiply it by this well-chosen one. And the only way that this can have a 5 on bottom is if I multiply it by that well-chosen one. And so I think what you see is the limit of a product is the product of these two limits times the limit as x goes to 0, 5 sine of 5x over 5x. But then I can take this constant and pull it out front. I can take this constant and pull it out front. So really what you're left with is the limit as x goes to 0 of sine of 3x over 3x times 5 sine of 5x over 5x, the limit as x goes to 0. But guess what? For this first one, I'm going to let theta equal to 3x. And notice that as x goes to 0, theta goes to 0. So I can rewrite the first one as 3 limit as x goes to 0, the sine of theta over theta. And then for this next one, I'm going to let theta equal 5x. And so as x goes to 0, theta goes to 0. It's going to be times 5 limit as theta goes to 0 of sine of theta over theta. But this is just equal to 1, and that's just equal to 1. So really you just have 3 times 5, which is 15. That's that problem. We will do more in the next video. Happy studying, and I will see you soon.